Chapter 6, Section 6, we're going to solve equations. Equations that have radicals in them, equations that have rational exponents in them. So we're gonna try to work our way through those. So just several examples here, and we'll encounter all of the different scenarios that can happen, things we got to remember from days gone by in this particular class, and maybe Algebra 1 as well. So let's start with a cubed root of 2x plus 7 is equal to 3. I usually put a little tail on the end of my radical so you can tell where it ends, because there'll be times when there's something that's not under a radical in there. So all of that is underneath that cubed root symbol. So what we want to be sure of when we're trying to solve these is that the part that has either the root or the rational exponent on it is by itself, so that we can get rid of that. So on this one, it's already that way. So what's the opposite of taking the cube root? Cubing. Just like the opposite of taking the square root is squaring, the opposite of taking the cube root is cubing. Okay. All it does on the left-hand side just takes care of the cube root. It's gone now, and we just have 2x plus 7. And on the right-hand side, we have 3 to the third power, which is the number. What number is it? 27. And now we have a really easy Algebra 1, 7th grade math problem to solve. So how do we solve that? Yeah, something we all know the answers to here. It'll be 2x is equal to 20. Yeah, divide by 2 is equal to 10. And then and that's the answer. And we just need to check it in the original problem and make sure that it works. So you plug in 10, and that'd be 20 plus 7, 27. What's the cube root of 27? It's 3, just like it says there. So that does work in that original problem. Okay. Here's a very similar problem written in a different way. We got a rational exponent that's a 1/3. What's the difference in the 1/3 power and a cube root? Is there a difference? No, they're the same thing, okay? So this is a very similar problem. It's just written with a rational exponent instead of a cube root. Okay, so understand that you could rewrite that as 2 cube root of x minus 3 is equal to 4 if you wanted to. I'm not going to. I'm just going to work it with the rational exponent. Is that stuff that has the rational exponent by itself? Was there anything in front of the cube root over here? No. Is there anything in front of the cube root over there? Yeah, let's get rid of it. How do we get rid of that 2? Divide by it. So if we divide both sides by 2, that gets us the x minus 3 to the 1/3 power by itself. Not square root, cube both sides. Reciprocal exponent is what that is. It's the same rule that we're using over here. Remember, 1/3 power and cube root are the same thing. This, to me, makes more sense. Because to get rid of a 1/3 power, you use the reciprocal exponent, which is a 3, and they cancel each other out. And then that gives us x minus 3 is equal to 8. And then we just add 3. We get x is equal to 11 outlet. Really, this is the first page is not too bad of this. Depending on how much you remember from past. How bad. All right. So this one we have what kind of root? Square root. They don't write the 2 in there, but it's there. Of x plus 25 is equal to 4. So is the square root stuff by itself? The stuff that's in the square root by itself? Yeah, there's nothing out in the front of it. So we can undo the square root now. How do we undo a square root? Square both sides. x plus 25 is equal to 16. And then we subtract 25, be negative 9, is that right? We want to check that. What happens if we get a negative underneath the square root? That's not good. It's imaginary, okay? So we want to check that. If there's a negative left underneath a square root or any even root, then we don't want that. Here, we got to check it. Negative 9 plus 25, does that stay negative, or is it back to positive? Back to positive, which works. So that one, get a negative answer. Sometimes you're going to throw out the negative answer. This time we're going to keep it, okay? Let's look at this one. This is where it starts getting a little bit more in depth. Well, this is not that bad, actually. This one's not. What part has the exponent? The x. So that 4 is not part of the exponent. So let's get rid of it. How do we get rid of that 4? Divide by 4. That's right. It's x to the 2/3 is equal to 9. Now, neither. I'm going to get rid of that exponent by using the reciprocal exponent, which you're going to multiply by 3/2, but it's as an exponent. And this is where, how much do you remember from before, comes in. So the left side just gets its x. The right-hand side, we've got an even denominator on our fraction exponent. So that means what should go in front of the answer? Good. Plus or minus. Good. So that's one hurdle we got to jump. Now we just need to work out what is 9 to the 3/2 power. It works out to be 27. 9 cubed would be 9, or it'd be. When is it compared to even denominator on a fraction exponent? Anytime you do the work and one of your steps is putting an even denominator on the fraction exponent, then that's when the plus or minus comes in. That's a very good question. It's a very important question. All right. So on this one, when we did the 3/2 power, that's what made the plus or minus have to be there. Now, when we plug back in to the original, does it matter if this is a negative number? Why not? What's the denominator of that fraction? It's odd, so it doesn't matter. Okay, it matters on the answers, but it doesn't matter in the original because the denominator of the fraction exponent was odd. So you can have negative answers there. Let's do one similar to that. 7x to the 3/5 equals 56. What's the first step for that one? Divide by 7, good. X to the 3/5 is equal to 8. How do we get rid of the 3/5 power? Reciprocal power is 5/3. Does this one need a plus or minus? Why not? Odd denominator on the fraction exponent that we put in there. All right, so what's 8 to the 5/3? 32. And just the positive answer there, because we didn't need to put a plus or minus because we didn't have an even number in the denominator. Well, let's put a negative number in there. Negative 2x to the 3/4 is equal to negative 16. What do we do first? 5 by negative 2, good. That works out nice because it turns that into a positive number. Otherwise, it wouldn't work. You couldn't have a negative number over there. Now, what do we do to get rid of that? 4 over 3. Does this one get a plus or minus? No, it had an even in the beginning, but what I didn't have an even in the denominator. So that would be 8 to the 4/3, 16. Final answer. Check it in the original. You can take the 4th root of 16 and then cube that answer. If when you get rid of the exponent, if what you put in there has an even denominator, if that's got an even denominator, that's when it has to be plus or minus. You can have a negative answer, but you can't have a negative number that inside of an even root, because that creates a complex number system, and we're dealing with real numbers when we're solving equations. We're going to get to some that get multiple answers, and that kind of makes it really clear when it works, when it doesn't. Let's do this: an x plus 2 to the 4/3 minus 1 is equal to 7. What do you do first? Add 1, yeah. Get rid of that stuff that's not part of the stuff that has the fraction exponent.
Hawkins, report to the office.
Okay. Now what? Okay. Reciprocal power would be answer's going to have plus or minus in it. So we got x plus 2 is equal to plus or minus 8 to the 3/4. So I'm thinking, what's 8 to the 3/4? Yeah, it doesn't work out real nice. So let's simplify it. This is where what you remember before comes in. 8, I'm going to break it down, 4 and 2. It's 2 to the 3rd power to the 3/4, which would be 2 to the 9/4 power.
You need to slow down right there.
All right, so I broke down. I'm trying to figure out what 8 to the 3/4 is, not as a decimal. I don't want a decimal answer. I want the exact answer. Then we'll get decimal answers. Okay? So I did the factor tree for 8, and 8 turns into 2 to the 3rd. So this is like 8 to the 3/4 power. That's what that is. And then I'm doing the exponent rule. 3 times 3/4 is 9/4. So I'm just changing that into multiply. Parentheses with exponent outside is multiply. So 2 to the 9/4. But is x by itself yet? No, so I got to simplify and get x by itself. So I'm going to subtract 2. So I have negative 2. No. It's going to be negative 2 plus or minus to the 9/4. 2 answers. Negative 2 plus 2 to the 9/4. And we're going to get a decimal approximation for that. Why would you make it 0?
Because plus or minus would make plus 2 would make it minus 2 makes it 0.
Negative 2 plus 2 to the 9/4. 2 to the 9/4 is not 2. It's a much bigger number. Well, maybe not much bigger, but it's bigger than 2. Studying war over there, I guess. So I'm just going to do negative 2. I'm going to use my calculator to get my decimal approximations to that. Negative 2 plus 2 raised to the 9/4. And we'll go 2 decimal places. It'd be 2.76. And then I would do the minus. So negative 2 minus 2 raised to the 9/4. It'd be negative 6.76. Get 2 answers there. Both of those are okay to keep because the original problem doesn't have an even denominator on the fraction exponent. Sometimes that's going to work out to be a nice number like it did earlier. Sometimes it's not. This is one of the knots. Let's look at one where it actually does work out to be a good number. I think that maybe would be better served to have done it first, but I didn't. So hindsight's 20/20. Okay, x minus 5 to the 4/3 power minus 3 is equal to 78. What's our first step? Add 3. So x minus 5 to the 4/3 is equal to 81. And now I can get rid of the 4/3 by using the 3/4. And I'm thinking, what's 81? Well, 81 is 9 and 9, 3 and 3. It's 3 to the 4th power. If it works out nicely, it does. What I'm trying to show you is what you do, whether it works out nicely or not. Because some of them are not going to work out nicely. Like this one becomes 3 to the 3rd power, which is 27. Because there's 1, 2, 3, 4 3s. So that's 3 to the 4th. 3 times 3 times 3 times 3 is 81. Right. So here we're looking for sets of 4 because we're to the 3/4 power, really. Okay. This is what I'm trying to show you is that if you'll think about that factor tree, whether it works out nicely or not, you kind of get a better understanding of what the factor tree even does when it does work out, so that you can know what it does when it doesn't work out.
So does this one work the same as the other one?
Yes, because I did an even denominator there, I've got
No.
No.
It's gonna be plus or minus 3 to 4.
3 to the 3rd.
I thought it was 3 to the 4th.
It's 3 to the 4th to the 3/4. The 3/4 power is here. 81 becomes 3 to the 4th. These multiply together to give you 3 to the 3rd. Okay.
How did you get to 3 to the 3rd?
4 times 3/4. The 4's cancel out, the 3's left. 4 times 3/4. 3/4 of 4 is 3. So this ends up being x minus 5 is equal to plus or minus 27, because that's what 3 to the 3rd is. We didn't do that on the previous problem because 2 to the 9/4 is not a good number. It didn't work out real nice. This one did. It worked out to be a good number. So we end up with 2 problems. Positive 27, negative 27. Add 5 on both of them. So x equals 32. You could, yeah, you could, but I'm trying to show step by that 3 to the 4th times 3 to the 3/4 power is 3 to the 3rd. This one works out nicely. The one before this did not work out nicely, so that's why it was 2 to the 9/4, and we left it that way. Because 2 to the 9/4 is not a nice number, like 3 to the 3rd is. And then here, negative 27 plus 5 would be negative 22. And those are our 2 numbers that are the solutions to this.
That's exactly what I think I can do.
All right. It's I. X plus 1 is equal to the square root of 7x plus 15. Is the stuff that has the rational exponent or the root by itself? Yes, it is. So how do we get rid of that? Okay, so if I square both sides, the right-hand side is the easy side. It's 7x plus 15. What is x plus 1 squared? No. X squared plus 2x plus 1. Because x plus 1 squared is x plus 1 times x plus 1. Distribute x squared plus x plus 1. And get it equal to what? No. If it's got an x squared in the problem, we got to have it equal to what? 0 to solve it. So we got to, yes, you are going to get your like terms together, but in a smart way so that you can solve it. So we end up with a quadratic. There's a lot of ways to solve quadratics. One way is factoring. One way is quadratic formula. The x thing will work on this one, yeah. -7 plus 2. So x minus 7, x plus 2. Set each factor equal to 0. Now, we got to check those. So if I check the 7 in the original problem, on the left side I get 7 plus 1 is 8. On the right-hand side, 49 plus 15 would be 64. The square root of 64, 8. Yes. Then I plug in the -2. On the left side, I get a -1. On the right-hand side, I get -14 plus 15 to be 1. Is the square root of 1 -1? Just -1? It's plus or minus. This side said just minus. So that answer gets thrown out because it does not check.
Why did we find that answer?
It's what's called an extraneous solution. Extra. The point is, the state of Tennessee says you have to learn this stuff, and I'm trying to teach it to you. That's as far as we can go with that conversation. Let's look at another one similar to that. 10x plus 9 under the square root is equal to x plus 3. So we can square both sides again. Same. This is a lot like the last one, just moved it around. Change the numbers. 10x plus 9. And on the right-hand side, what do we have? You add in the middle, not multiply. And if you've got to go over here to the side and write out x plus 3 times x plus 3 and do the distributive property, that's fine. And nobody's going to make fun of you for doing that. That's part of doing the work. Okay, and then that in the middle is where the 6x comes from. Right. When you go to simplify and get your like terms together and get it equal to 0, the 9s do cancel out. I said 9 and wrote 9. So that'd be 0 is equal to x squared minus 4x. And then it's a quadratic again, so I got ways to solve that. Factoring would be, it's not a trinomial, so the x is not one of my options, but factoring still is. What's the GCF of those two? X. They both got an x in common. It would leave x minus 4 inside, and then you set each of those equal to 0. That one's done. This one would be positive 4. And then we need to check those in the original, see if we need to throw one of them away. It's possible that both of them work. So if I plug a 0 in, that'd be square root of 9, and 0 plus 3 is 3. So square root of 9, 3. Yes, there's not a negative sign in there that's causing a problem. 4 plugged in there to be 49. 4 plus 3 is 7. The principal square root of 49 is 7. So that works as well. Okay. When there's a square root already in the problem, you're only looking for the sign that it's in front of it. If there's nothing in front of it, it's considered to be a positive square root. So the positive side is what you're checking when you do that. Okay. Let's look at a tough one. All right. So this one kind of breaks the rules a little bit because there's two radicals in there. Okay. And the question would be, okay, well, how do you get the radical stuff by itself? If you get them both on the same side, can they combine? So to combine, you would have to either be multiplying or adding or subtracting one, two that have the same stuff inside, and these definitely don't have the same stuff inside. So we can't combine them. So what we've got to essentially do is get rid of one of them, and then get rid of the other one afterwards. Okay, so right now this one's by itself, the 3 minus x. So I'm going to square and get rid of it. That side's easy. The other side's not so easy, because that means square root of x minus or x plus 2 plus 1. No, it does not get rid of it. Not like that. Because you're getting rid of this radical on the right-hand side. We're eventually going to be able to get rid of the one on the left-hand side, but not straight away. So we've got to do distributive property on this side. Square root of x plus 2 times square root of x plus 2. Then that radical goes away to just get x plus 2. That's that times that. And then plus 1 radical x plus 2. And then distribute the 1. Another 1 radical x plus 2. All right, so square root of x plus 2 times square root of x plus 2 gives you just x plus 2. The square root goes away. The reason it goes away is because you end up with this x plus 2 squared inside. And this squared and that square root cancel each other out.
So then instead of us having to do all that long work, why don't we just eventually work out to be x plus 2?
We are going to. Eventually it will be. It's not yet. Like, these radicals don't go away. They're still there. So when I square this side, this radical goes away. When I square this side, I don't have just a radical over here. I have a radical plus something. So I'm having to multiply this whole side times itself. So it doesn't just magically go away. I mean, it's got to multiply out this whole side times itself. And that's what this is.
So the 2 square roots on the last problem, do they cancel each other out?
No, they combine, because you have 1 plus 1, which would be 2 radical x plus 2. Then on this side, right here, we got x plus 2, and then there's a plus 1 out here. So that's a plus x and a plus 3. Now, are there some like terms that can move over to the other side? The x and the 3 could move over there and just get out of the way. That'd be nice. So let's do that. So these cancel. There I have 2 radical x plus 2. And then the 3's cancel, but I have a negative 2x. Divide by 2 to get the radical by itself. So we're about to finally get rid of the radical x plus 2. Now, is that radical by itself now? Yes. Now we can square to get rid of it. Well, x plus 2 is equal to what? Is it negative or positive x squared? Positive. Anytime you square anything, it becomes positive, right? So negative x times negative x would be positive x squared. It's got an x squared in it, so that means it needs to be equal to 0 to solve. Okay. Yeah, move everything to one side so that it's equal to 0. And then factor it. Be negative 2 and 1. So x minus 2 equals 0. Now we got to check them. That's a negative 1.
What do you mean by checking?
I mean, go back to the original problem and make sure that there's not a negative underneath the radical.
Well, there's gonna be.
I mean, with which one?
With both of them.
Is it? If I plug in positive 2 and the left side, so I'm going back to the original. Square root of x plus 2 plus 1 is equal to the square root of 3 minus x. If I plug in positive 2, that's going to be 4. That's not negative. If I plug it in here, 3 minus 2 is 1. That's not negative either. So that works.
So how do we know which?
If I plug in negative 1, negative 1 plus 2 is positive 1. That works.
No, like I get that, but what I'm saying is, how do you know which numbers to put in the blanks?
The ones you get as answers.
I get that, but I'm saying like there's 2 different. Like,
You put one in at a
Does it
time.
matter if I put negative 1 in the first one?
You have whatever you put in this one, you got to put in that one. You can only check one at a time. So I'm saying check 2.
Yeah, like I get that.
And 2 goes in everywhere there's an X. And you decide if it's right or not. Then you start over and you check negative 1. You plug it in everywhere there's an X. Is it right or not? And when you plug in the negative 1, we get 3 minus negative 1 is 4, which is the square root of 4 is 2. On this side, we get 1, square root of 1 is 1, 1 plus 1 is 2. So both of those, or the negative 1 works. The 2, we end up with 4, 2 plus 1 is 3. This side, we get 3 minus 2 is 1. What's the square root of 1? So does the 2 work? No. Even though it's the positive answer, it gets thrown out because it doesn't work on the problem. Negative 1 happened. It did work. 2 did not work. It's an extraneous solution is what it's called. Extra solution is what it's called. Okay. This takes a lot of what we've already done before. It says do it some more. Not exactly easy to say the least, but it is what it is. Okay, so you've got the rest of today, tomorrow to work on this. This is what we're doing to practice it, get better at it. Tomorrow's Tuesday. We got Wednesday. We'll do a review of the whole chapter, and then Thursday we'll test the whole chapter. Okay, so you got 2 days here to be better at it, I guess. I don't know what's the best way to put it. Page 456, 3 through 52. All. You need to practice. Y'all need to practice on that. You got 2 days to do it. So. Some of these are quick and easy, like the very first ones we did. Some are not as quick and easy. The not as quick and easy are toward the end. Okay, in case you hadn't checked, on this stuff, it starts out real easy and then it just steadily gets harder. Does that in each section.